In this video, we're going to discuss the derivatives of logarithmic functions. So the first one is that if you just do the derivative of the natural log of x, you get 1 over x. If you do the derivative of a different log base, whatever a is, of x, we're going to go to 1 over x times the natural log of a. So if you think about this being log base e is natural log. So you'd have 1 over x times the natural log of e, and the natural log of e is 1, which is why we can reduce that down to just 1 over x. And then if we have the natural log of some function, a couple ways you can look at it. You can look at it as the derivative of the function over the original function, but what's really happening here is you're doing 1 over whatever's on the inside, so 1 over g of x, but then you have to chain on the derivative of the inside function, which is g prime, and the chaining on of g prime can be put on top as opposed to out to the side. You can do it either way. That's up to you, whether you want to write that as 1 over g of x times g prime of x or g prime of x over g of x. Either way is fine. So let's jump into some examples. Differentiate y equals the natural log of x cubed plus 1. So y prime, I'm going to do, I've got the natural log of a function, so I'm going to do the original function on bottom, x cubed plus 1, and then I'm going to chain on, so I'm going to put this on top, I'm going to chain on the derivative of the inside function, which would just be 3x squared. Next, we have the natural log of sine x. Again, that's going to be sine x on bottom, the derivative of that on top, which would be cosine x. Cosine x over sine x, you could leave it there. I'm going to go ahead and simplify this down. That would be cotangent of x. Okay. Number 3, f of x equals the square root of the natural log of x. So I'm going to rewrite this function first as the natural log of x to the 1/2 power, right? That's square root. So to do the derivative of this, we are going to need to start with the outside function, which is the square root. So I'm going to do the power rule. 1/2 times the natural log of x to the negative 1/2 power, and then I'm going to chain on the derivative of the inside function, which would be 1 over x. Right, the derivative of natural log of x is 1 over x. Number 4, f of x is the log base 10 of 2 plus sine x. So f prime is going to be, I'm going to do 1 over, it's 1 over x ln a, right? So that's what we've got right here. And x is the stuff on the inside. So 1 over 2 plus sine x times the natural log of a. Well, a is 10, so it's that times the natural log of 10. All that's on bottom. But then we have to chain on the derivative of the inside function. So I have to chain the derivative of this, which would just be cosine x. And again, I could put that on top if I wanted to, or I can just leave it out to the side. And the last one, we want to differentiate the natural log of x plus 1 over the square root of x minus 2. There's a lot of stuff involved here. I'm going to start with the outside function, which is the natural log. So we're going to do the derivative of natural log. So that's 1 over the original function, which would be x plus 1 over the square root of x minus 2. And then we're going to chain on to this the derivative of the inside function, which means I need to do the derivative of this, which is a quotient. So I've got to chain on a quotient rule here, which means we do the bottom times the derivative of the top, which would be 1, minus the top, x plus 1, times the derivative of the bottom, which would be 1/2 x minus 2 to the negative 1/2 power, all over the bottom squared, which would just be x minus 2. And that's our derivative. You can simplify that a little bit. First, this, I'm not going to, but this, if I do 1 over a fraction here, I could just make that, I could just flip that as the square root of x minus 2 over x plus 1. But you could also just leave it as 1 over this fraction here. And there's a lot of stuff I could do here to simplify on the inside of this part as well. But that is our basic rule. We're just adding in the derivative of natural log. But make sure, again, you're always on the lookout for chain rule application, product rule, quotient rule, and things like that.